Hi folks, and welcome to my tutorial on test meters. I'm just getting prepared and set up and ready, and basically we're going to cover two types of test meter in this tutorial. We're going to cover the old style analog meter, and we're going to cover the, or I should say, traditional analog meter, and we're also going to cover the more modern digital meter. We'll start with the digital meter, and we want to put this onto volts, and what we're going to do, we're going to measure 5 volts. So we've got our power supply with 5 volts going in, 5 volts coming out, sorry, and there you go, 5.4, 5.04, that's good enough, and that concurs with the power supply. And this meter is actually fairly accurate. It's my my go-to meter. You all know that. Now, the reason why I like an analog meter as well as a digital meter, I like to have an analog meter for one purpose. See, we've got our 5.4 going in there. Yeah. Now that's a stable voltage. But what if it wasn't stable? What if it was doing all this malarkey? See? Can you make head or tail of that? Yeah, I sure as hell can. Put us back down to where we were. That's as near as, damn it. Just come down slightly. There we go. That's can never get it back right. There we go. Oh. There we go. Right. That's one thing a digital meter can't tell you. A digital meter, unless it's got a scale on it as well, a digital, but which most don't, a digital meter cannot tell you about what a fluctuating voltage is doing. Now, if we go to DC, which we are on, we go to volts on our traditional AVO meter. We want to be on the 10 volt range. And I can't see the ranges on this that well because that's the Jesus. That's the 10 volt range. Now, if I just put that probe aside and get the analog meter, now, and we'll do the same test. There we go. 5 volts. You read it from the DC scale here. So, you know, you actually subtract your voltage, and that's giving us 5 volts. That equates to 5 volts. Or you can put it on the 100 volt scale, and that'll give you just under 50, which is 5 volts. So we go back to the other one, it flicks right over, which is too much. Anyway, what does capacity do? Nothing on here. Anyway, now if we go back to our power supply. Now let's just get the meter in view. I trust you can all see that. That's the needle there. So if I now throw the voltage about, you can see. No matter what I do, you can see that something's wrong because the voltage is moving about. So if we put it back on there, and that's definitely our 5 volts, which is right. You know, and that's where an analog meter comes into its own. This analog meter needs a service. It's a switches are a bit dirty. I'm going to do it in a bit. I might take you through that, we'll see. But when it comes to accuracy, a digital meter is always better. You know, I'd rather take my voltage measurements with that than with that. But in the time before this, that ruled. Until they brought the Avo 8 out, of course. Mine's an Avo 7. Anyway, and I only gave a £5 for it at the swap meet. Now, let's move on to resistors. Now, we've got a resistor here, and this is an 80 ohm resistor. This is an 80 ohm resistor. So if we put the meter, we'll leave it with DC where it is. But first of all, let's turn off our power supply. Disconnect our probes. I nearly switched it then with the... Always remember to disconnect your meter before you change the range. Now we want to go to ohms, and I want to put it on. There we go. I've put it for this. I've put it on times. I can't read the ranges. Times 100,000, I think that fucking is. Anyway, so what we'll do, we'll measure the resistor with the analog meter to begin with. And that's coming in at 90 ohms. So make sure we're zeroed. We're not quite zeroed, so let's bring it in a bit. There we are. This meter needs cleaning. There we are, that's zeroed enough. Right, we're coming in at just over 90 ohms on an 80 ohm resistor. That's not bad. It's not bad for an old meter. You know, that's you know, it's 10 ohms out. But then again, resistors are tolerant. The tolerances on them can be 5, 10 or 20% out anyway. So, you know, but if we now go to the digital meter, I'm only talking about meters in this tutorial. Other test instruments I'll do separate videos on. Now let's see what the resistor tells us on this meter. Let's put it on ohms. This automatically sorts everything out for you as well, a digital meter. The analog meter is a bit more involved. And that's 81.8 ohms. So we're 9 ohms out. This is 9 ohms out, which is not bad. It's not bad for an old meter. You know, I can accept that. In fact, if I came across a resistor using this meter, I would actually leave the resistor in. Because 9 ohms is neither here nor there. Now, speakers. Speakers are measured in impedance, but a speaker is technically an inductor. But your meter reads it in ohms. Now, we've got here, turn the meter back on, we've got here a 4 ohm speaker, supposed to be 4 ohm, but I think these read about 6 or something fucking daft. There we go, 0.7 ohms, they're supposed to be 4 ohms. Actually, I think they are anyway, I think they're supposed to be 4 ohms. Either 4 or 8. Anyway, that's what that speaker's telling us. Let's look at the other speaker, because I've got two exactly the same. So they probably are 8 ohms. I've not looked at the back of them for ages, but this tells us, doesn't it? Yeah, 8 ohms. Yeah. Now, let's test the same speaker with the analog meter. Let's change the range. I'm just making a video. I'm doing a tutorial on the multimeter.
Oh, that's nice. I'll go in there.
I'll be in a minute.
Okay.
And that one's reading actually. That one's reading 7 ohms. Well, just over 5. So I'd say, you know, yeah, that's not bad. So yeah, we're getting what? About 6 ohms. So that's not bad. I can accept that. Now let's just have a look at the other speaker because they're exactly the same and they should give exactly the same reading. So we'll just give our other speaker a quick test. See, this is really aimed at people who, there we are, exactly the same. So they are actually 8 ohm speakers, but they're coming in at 7. So that's good enough. You know, but for those, you know, this tutorial's really aimed at those who, it's aimed at beginners who haven't really got to grips with the multimeter. Right, I'm going to eat my Magnum. I'll be back in a minute. My daughter's just brought me a Magnum. Right, we're back. If you hear a voice in the background, it's my daughter. She's sat in my front room. And right, that's me kicking the tripod. Right, where were we? Now, let's test a diode on the analog meter. Show you how to test a diode. This tutorial, I will remind, is for beginners. I'm not trying to tell people who know about it how to suck eggs. It is purely for beginners, people who are just getting into it, or people who are unsure. And basically a diode, it's a semiconductor, therefore should only read one way. There we are. Turn it round. Nothing. And that's how you test the diode on the analog meter. Get a reading that way. You get fuck all that way. Now, if we go to the digital meter and we do the same test, now we're on ohms. That's jumping around a bit, but then again probably because of picking up resistance off me. Nothing. That side. We get our reading that side. But digital meters have a diode they do have a diode tester in them. So if I just put the meter there, what it'll do, it'll put 5.19 millivolts into the diode, and that tells us that the diode's good. If we flick the diode over, nothing. And that's what you should get from a diode on a digital meter. Now, if we find ourselves a transistor, I'm trying to think where there's a transistor. Here's one. Oh, look at that. Just conveniently have a transistor. Don't know whether it's a good one. But there again. It's part of the fun, isn't it? Finding out. So we've got a transistor here. Pull these insulators off it. There we go. Right. I don't know which is the emitter or the base on this, but I know the case is collector. It always is. Or in my experience, it always is. And probably in everybody else's experience. So what we'll do, we'll show you how to test the transistor with the analog meter. See, we've got a connection there. Right, move this down the scale because we're up a bit there. There we are. Right, reads on that leg. Reads on that leg. Now we know the transistor's not short because the needle isn't going all the way across. If I short the probes, then it goes all the way across. Now if we swap the probes over, to the other side, we get nothing. So we go back this way. Oh, nothing on that one either. We've got something on it. We had something on it before. Oh, that was why. Put the leads on the wrong way around. So that way is nothing. Nothing. And that way, that tests your transistor. So you know your transistor's working. So we know the transistor's okay, or at least it's okay on the meter. I mean, it could test, or it could test. Now you could put it in something that could be faulty, but I had that problem with it. Shut up! I had that problem the other week, if you remember, with the ITT amp. The transistor tested okay out of the circuit, but in the circuit it was playing up. So now if we use the diode tester, 4.5, 4, 6.07, 6.07. Now if we go the other way, whoops, nothing, nothing. There we go, you see. Now if we go down 2 ohms, in case you don't have a transistor checker on your meter, go 2 ohms, nothing, nothing. .8 ohms, 0.4 or 4.14 meg ohms. So yeah, I'd say that's a good transistor. I do have a transistor checker for checking these, but we'll do that at a later date. So we've done a resistor, we've done we've done a resistor, we've done a diode, and we've done a transistor. Now let's do a capacitor. Now, this meter doesn't really do capacitors, but you should be able to get an idea because of the way it behaves. There we go. It'll charge up and then it'll say open line. And then if we go the other way, or the other way even, there you are. Now we'll put it on the other way. Works the opposite way. There you are. That gives you an idea that capacitor could be okay. It's certainly not open. It's certainly not open circuit, and it's not short. Now, if we go to the analog meter, and we test the same component, nothing. I think the meter just flinches slightly. Let's come down a range if I can. Yeah. It's going all the way over, but that's no problem. Nothing. The meter just flickers slightly. I think it does. Let me just turn it to me so I can have a look. Yeah. The meter just jumps slightly. So that tells you that the capacitor's not short and it's not open. So we've done a resistor, a diode, a transistor, and we've done a couple of speakers on both meters. We've done DC voltages. AC voltages I won't cover because you set your meter to your highest AC range if you're looking for 240 volts, and you check 240 volts. In fact, what we'll do, we'll actually do a quick AC test. We can use the Variac. If the Variac's plugged in, which it isn't. Let's unplug that music centre for a minute. Variac's now plugged in. Set our meter to AC, and we want the voltage range. We'll go to 1000 volts and we'll pop our probes into our Variac, and what we'll do, we can actually come down a range. There we are. We're putting what? I'm just looking for the AC scale. Not the very fucking top, is it? Where I can't. No, that's ohms at the top. DC. Right, so it must be. So we're putting set this so it's putting 50. That's 50 volts. So, oh, I've pulled the fucking hell. Oh yeah, that's what I wanted to do. So if we now plug our digital meter in, pop that up there. Now this digital meter, my meter sets it all up itself. The bench meter there doesn't, and that's why I'm using this. Because most meters these days do set it up themselves. So the variac's on. So let's wind it up. And we're at 35 volts there, so let's take it to around 40. Let's take it to around 50. There we go. $50 exactly on the analog, on the digital meter. It's 50 volts. So we'll leave that at 50 volts. Turn the variac off. Now we can connect our analog meter and see if that concurs with the digital meter. I don't expect it to, but you never know. Might be a bit more accurate on AC than it was on DC, but it weren't that far out on DC. Let's put our probes back into the variac. Let's turn this on. There we are. And we're just under 50 volts. We are what? Yeah. That's showing us about 45 volts. So that's about 45 volts. So it is a little bit out. But there again, like I'm always saying, you know, the older meters, they weren't as accurate as the new ones are, but they're still good enough to get the job done. I mean, if you're 5 volts down, you wouldn't worry about it. If you're using one of these, you wouldn't worry about it because you're going to expect it to be a little bit lower. You know, this probably needs a service as well, but you know, but I think it's performing quite well for what it is. And where do we want to go next? We've done AC voltages, we've done DC voltages, we've tested the most common components that you would test. I haven't got any inductors, but there again, inductors are just a short circuit more or less anyway. And we've tested a resistor. A fuse, that's just a short circuit. Continuity. Now you can do continuity on here, but you don't get a bleep. Continuity on here, if we get a component, there we are. Right, so put it back onto there, onto DC, and turn this back to ohms. That's your continuity. So you connect them two together or across a piece of wire like I've done there. It's continuity. That's, you just don't get the bleep. Now on a modern meter, you can do it the same way. Would help if I pick the right leads up. And put the meter there so we can all see what's happening. See, your 3 zeros indicates continuity. But in case you don't want to look at your meter on these, you can press the AC/DC button whilst on ohms, and it'll switch between ohms or continuity. There we are, we're on continuity. That indicates that we're getting, yeah. Now if you try testing a diode on continuity, it doesn't work. See, nothing that end, and nothing that end. So you can't test the diode that way. Not on this meter anyway. We'll just do that again just in case. No, but I'm definitely right. There we are, you see? Nothing. So, and a transistor you can't do, I don't think. A lot of these meters have a transistor checker built in. You got an NPN and PNP. And it tells you your emitter base collector and stuff, information there. I never use that. You'll see why in the next video. See, nothing there. Oh, that's me shorting it on the case. Nothing there. Nothing there. That's me shorting it out. Nothing there. Nothing there. Right. Right, so that's your 2 most common forms of test instrument, test meter. I do suggest that as well as having a digital meter, you also have an analog meter as well, because although you won't use an analog meter much, turn that off because it's heavy on the batteries, my meter. Because you won't use a meter that much, an analog meter that much, you know, it's still worth having one in your, you know, in your workshop. It's still worth being there, because there are times when you do use it. I mean, I don't use this that often, but I do use it. I'm going to give it a service, and what I'll get the service information, and we'll try and go through that together and service this old girl. See if I can perform a service on it. If not, then I'll find somebody who can, because I'd like to have it serviced. I mean, it's pretty accurate now for what it is, but it's not as accurate as this. But then again, it probably never was, you know. But that's basically, in a nutshell, that's basically your test meter. You know, you want it for resistance. You want it for inductance. Well, if it reads inductance, basically the functions you want your meter to perform is resistance, which is ohms, voltage, AC and DC. You want to get a meter with the highest voltage ranges you can. All my meters go up to around about 1,000 volts. You're never going to test that much voltage, but you never know. It's always worth it, you know. Most meters stop at about 750 AC, digital ones anyway. This old analog meter here, the Save 07, I need to repaint the ranges in, you know. I'm going to do that when I do the service. I'm going to, because they're all sort of like indented in, they're all sort of embossed in. So I should be able to just paint over them with white paint and then just wipe the excess off, you know. Paint that'll actually come off rather than knacker the control up. I've got some somewhere. I've used it on radios, and you wipe it off after you've done it, and it leaves the indentation, leaves the paint in the indentations, or even a white permanent marker. I used a black permanent marker on the Bush, on the Bush VHF 41. As you remember seeing if you've seen the video on the restoration of that particular radio. Right, in the next video, I'm gonna leave it there on test meters because I think I've covered. I've covered AC voltage, fluctuating DC. I've covered AC voltage. I've covered DC voltage. I've covered fluctuating voltage. I've covered. Hang on. You heard that dopey fucker. Owl's at the ice cream man. Well, there we go. Probably wants an ice cream. Anyway. The other important thing is meter accessories. Let's talk about meter accessories. Now these probes here, not these, that's the AVO. Let's just separate the probes. Now the AVO 7, I haven't really got any accessories for the probes. I do need to buy a new set of probes for it actually. I want to buy a set of these. And the reason why I want to buy a set of these for the AVO 7, the reason why, if we just bring them into shot, they look like an ordinary set of meter probes, but they're not, look. You can screw the probe off, and there's a few accessories. We've got some clips. Where's the black one gone? It was here a minute ago and I threw it back up there, didn't I? Because I couldn't screw it onto here. Never mind, the red one. Oh, there it is. No, it ain't. There it is. The red one will do. I'm only demonstrating. Now what you do, you would screw that onto your probe, and you can then clip that to your chassis and to your ground on your chassis, and then you can you can poke around then, you know, without having to jam it in some way. You can just clip it anywhere convenient and then just poke around, because you are supposed to use, when you're working on valve, it's best to keep one hand one hand in the chassis and one hand out. On high voltage stuff, always keep one hand sort of in your pocket or out of the way of the chassis, clip to the ground and probe away with your positive. Right. The other thing is, but the other difference between the two meters is digital meters can read negative voltage. Analog meters can't read negative voltage. Not this one anyway. I don't know whether they made any that can, but these, there's a bit of dust on. There we go. This can't read analog voltage. If you put this can't read negative voltage. If you put the probes the wrong way around in this meter, the needle just goes backwards, and that tells you nothing. But on the digital meter, when you test the negative voltage, a minus comes up here in your display. You get a minus in your display here, or wherever the manufacturer put the minus, and it'll say minus maybe 10 volts, and that's that means you're on a negative rail. If there's no minus there, you're on a positive rail, and that's basically one of the good points on the digital meters. I mean, the digital meters have a lot of good points above the analog meters. Analog meters look nice, but they're not as accurate. They can do fluctuating voltages, but your digital meter can do everything this can do. This can do everything and more that this can do, but this can't do fluctuating voltages because it's just a series of numbers and you can't work it out. So basically, you know your voltage is unstable, but you don't know, you can't be sure. But when you put it on air and you see the meter swinging about, and then you know for sure that your voltage is unstable. So that's the two sorts of most common meters. In the next video we're going to look at dedicated testers. the Peak Atlas the Peak Atlas dedicated component analyzers. We're going to look at those in the next video, and we'll do some capacitor ESR checks and stuff like that, and we'll look at a whole range of components and speakers and inductors, stuff like that kind of thing. Anyway, I'm going to leave this video here because I think it's gone far. I think it's gone on long enough. I'm going to leave this video here, and I hope you enjoyed the tutorial. I hope you get something from it. If there's anything I've got wrong, then if anyone's more experienced than me and they think I've got something wrong, then by all means, don't be rude about it, but tell me. Tell me I'm wrong if I've said something wrong, and tell me. And because knowledge is power. I mean, I don't know everything. I don't even pretend to know everything, although people think I'm a know-all. What?
I said no one thinks that. The only person that thinks that is you.
I don't at all.
Yes, you do.
And you keep your 2 pennies worth out.
No.
Anyway, I've said it before and I'll say it again.
What?
If I want to listen to an arsehole, I'll fart.
You do.
What, want to listen to an arsehole or fart?
No, you just fart all the time anyway.
Yeah, well, means my body's healthy. Anyway, getting back to it, if there's something I don't know or something I've got wrong, then please tell me. Because like I say, contrary to what my daughter in there says, I don't know everything. I don't even think I know everything. I'm still learning as well. But I think I've covered just about everything. I mean, what else can you cover on a meter? I mean, I've covered voltages, resistances, transistors, diodes, speakers, AC and DC voltages, fluctuating voltage. I've covered the whole bloody lot, I think. I've been very thorough. I'm used to using this meter. I'm not used to using this because I don't use it that often, and like I say, it does need a service. And this meter's a lot older than me. It's a lot older than most people. This is getting on for what? It's got to be around 70 years old, hasn't it? The Avol 7. I'll have to find out when they stopped making them and see if there's a date code somewhere in this thing. Anyway, folks, you all have a good day, and thank you very much for watching. And don't forget, join me on the next one when it will be dedicated component analyzers, and we'll take a look at them. I'll tell you about the company that make them and show you what they're all about and explain why they are worth every single penny. Catch you later, folks. Bye for now.